Yeah, well, I can do a little discourse on medicine and science. And so the question is, how do you, if you decide you want to become an immunologist, how do you go about that? And the routine way in our country is that you go to college and then you go to graduate school, and so you go to a graduate school that you choose to go to, and you usually choose the graduate school to go to because you want to work with a particular professor that you've heard about or know what they're working on. And so it's a very personal kind of educational process. You go to become an apprentice with a professor who works on XYZ. And because of the fact that immunology is a branch of biology that has been more of a science in the last 100 years than it has been a part of medical medicine or medical practice, the majority of working immunologists have PhDs rather than MDs. And so when you go to graduate school and you work with famous Dr. Smith, you then he's working on several different projects that all relate to what he's interested in, and ultimately you focus down on a particular aspect of what the whole lab is working on, and there's usually half a dozen or a dozen or even 24 people in a lab at various stages of their training as either graduate students or postdocs, so that they've graduated from graduate school and now you do a postdoctoral experience of several years. And you learn from each other too. You don't only learn from the professor, you learn from your peers, and you learn from the postdocs that are a little bit older than you. And it takes anywhere from 5 to 7 years of graduate school to finally go through the whole process. And as a consequence, you really become an expert in whatever the questions or the problems that you've been working on. At the end of the whole process, you write what is called a thesis, which is a book. It's a book that compiles all of the things that you've learned about in your 7 years of focusing down on this particular problem. And so you really are, when you get out of the other end of the chute, you really feel like you know more about this than anybody else, essentially, and you do. But the only thing is that you don't know about a lot of other stuff. And that's one of the reasons that your education continues on into the postdoctoral years, which are usually anywhere from 2 to 6. And so the shortest way through all this whole process is about 7 years, and the longest part is around 10 or 12 years. So if you graduate from college when you're 22 and you go through this route, you could be 32 before you really are considered to be trained in the discipline, where you can then apply for jobs at companies, or you can apply for jobs at universities and so forth. So that's really the way the majority of people become immunologists. Now, the problem with that is that you've got a very focused education and expertise and knowledge, not only in terms of the theoretical aspects of the discipline, but also the technical things, the experiments, the experimental methods and procedures that are used for this particular discipline. And you can become an expert in doing those experiments. If you're good, you're the best of the best. Now, the problem is you don't have a broad intellectual education on the one hand, and you also don't have a broad technical education, which is another reason that you go from your graduate school years on to the postdoctoral years, because what you usually do in that instance is that you choose another discipline that's related but unrelated. And so that you broaden, this is when you try to broaden yourself. And some people take 2 or 3 2-year postdoctoral fellowship years, so that they go to one lab for a couple of years and another lab for a couple of years and then another lab for a couple of years. And during that whole process, the other thing that happens is you meet people. These people are going to be with you all the rest of your professional life. Some of them become your best friends, some of them become your worst enemies. And that's what happens, as in life as time goes on. So that's one route. And the other route is the route that I took when I went to medical school. And in medical school, what you get, basically both graduate school and medical school are like learning a foreign language. It's a language school. And you're learning, what the words are and what they mean, and so that you can now begin to use those words and use that new language in talking to other people that also know that language. And that's one of the reasons that it's difficult to sort of come in and later on and try to grasp, really what's happening in a particular field in science. And so in medicine, you learn a whole new vocabulary, but the other thing you learn is that you learn a very broad but superficial education of the human body, because it's focused on, humans. So you learn human biology, and you learn about all of the things in the body, how it works, what's going on, what different organs are, and how it's all regulated and so forth. But in addition, so that's just the biology, the physiology, but you also learn the pathophysiology. You learn what happens when something goes wrong in the heart, for example, the cardiovascular system, or in the immune system. And you learn what goes wrong, and you also learn what's available in terms of drugs or surgical techniques or diagnostic techniques and so forth, how to find out about what's going on and so forth. And it takes a long time to learn all that stuff. But at the end of 4 years, and you've got a pretty good grounding in the whole human body, and you know a lot about a lot of stuff. But it's just like the graduate school experience and the postdoctoral experience. In order to really use the new language that you've learned in the 4 years of medical school, you've got to do what we call a residency, where the young doctors spend anywhere from 1 year to 6 or 7 years in learning their specialty or their subspecialty, in terms of how they're going to, what kind of a doctor they're really going to be. And that's where you learn to speak the language and use the language. It's not just that you can understand it. And after that, and that whole process, for me, it took, I grew up during the Vietnam War, so I was supposed to go to Vietnam, but I applied to the National Institutes of Health, and so I got out. I didn't have to go to Da Nang, but I went to Baltimore instead, which was just about, I saw a lot of gunshot wounds in Baltimore. So I did that for 2 years, and then, and then I started to become a scientist. So I only did 8 years of medicine, essentially. And then I did 2 or 3 more years of science after that. So that's what happens to the MD people that decide to go into immunology on the one hand, or any other discipline in biomedical science. you have to then sort of almost duplicate what the PhD people have already done. Now you've got to do what they've done, and you got to know, because you're going to be competing with these people, and those people are going to be writing grants or trying to get jobs or whatever, and so they're being evaluated by all the rest of whoever's going to hire them or so forth. And so you've got to be able to demonstrate that you are better than those people. So I think that's all I want to say about those two aspects. And so for me, but what the good news was, because of the fact that I had this sort of total body experience of pathophysiology and pathophysiology, I looked upon the problems in immunology much differently than the PhD people, because they were focused down on dotting the I's and crossing the T's and so forth. And I had a much more global feeling for the whole thing, and that I used that to my advantage. So in immunology, I got into a new field of immunology, which is now known as cytokine biology or interleukin molecules and so forth. And those are molecules that the cells of the immune system make, that are messenger molecules between cells, and they tell other cells what to do and how to do it and so forth. And the way that they do that is that these molecules are secreted by the cells of the immune system, and they bind to receptors on other cells. And they bind in exactly the same way that hormones from the endocrine system bind to receptors and give, as a consequence of the binding, they give signals to the inside of the cell that tell the cell what to do next, essentially. And at the time that I was involved in trying to understand this whole process, the immunologists were not interested in this business at all. But I thought it was very fascinating, because I had already had endocrinology and all about hormones and receptors. And we also had the same thing in pharmacology, because most of the drugs bind to receptors that happen to be on cells and so forth. And then look at what's going on with COVID-19. It binds to a receptor that's expressed on lung cells, heart cells, intestinal cells, and kidney cells. And so the signs and symptoms of the infection end up in those organs. And it all has to do with exactly the same sort of biological process of how signals get conveyed from one cell to the next and so forth and so on. Well, the immunologists really were not interested in that. So I had an open field for 5 years that I exploited my expertise on the one hand, but also my hypothesis making as to how to try to figure out this whole process. I started out with a hypothesis. Well, this is the hormone system. This is just like I learned in endocrinology and so forth. And it turns out that was absolutely correct. But I don't think most immunologists still agree with that. What can I do?